Alright, our next theorem is called the tangent chord theorem. So let's review tangent right here. It's even labeled tangent. Tangent is a line that touches the circle at one point. It's right there at B. And a chord is just a line with endpoints on the circle. So there's my chord. And this kind of looks like an inscribed angle if you remember. So maybe that's going to come into play. This is an angle formed by an intersecting tangent and chord. That's exactly what I thought. The vertex is on the circle. So if you remember your inscribed angle, this is a similar, this is actually the same thing. Inscribed angle is also half or times 2. So it says right here, this is times 2 to get to here. So if this is 148, all we have to do is cut it in half and get 74. So anytime you get a problem that looks like this, you just either cut this in half to go here, divide by 2, or multiply by 2. There we go. Pretty simple. Alright, so this is our tangent chord. We are given the big angle, 148. Now we're going to divide by 2. We're going to take this number and cut it in half, divide by 2, and get 74. There's my angle right there. So if I go from big to small, divide by 2, and we're good to go. Okay, so in this problem, we're given the angle right here. So we're going to go from small to big. If I go from small to big, I'm just going to times by 2. So 65 times 2 is 130. So 130 degrees. Okay, with these two, it's just as similar as what we've been working on the past couple problems. So we're given the big angle here. We need to find the small angle. If we go from big to small, I'm just going to divide by 2. Or just cut it in half. So half of 90 is just simply 45 degrees. This one, we're going from small to big, so we're going the other way. So small to big, which multiplied by 2. So this would be 78 degrees. So that's 39 times 2. Alright, in this problem, it is using a similar theorem that we've been using, but if you notice, guys, it is asking you for this arc. And then if we actually do this, oops, let's get a different color so I can show you. The question mark goes with this one. Alright, so if you notice what I just did with those two colors, I just highlighted the entire circle. So if you remember, we've done this before, the entire circle is 360. So that means the yellow is 190. That means I could probably find the purple by taking 360 minus 190. 170 degrees. That's the purple. Now, I know the purple, so I can get my question mark, which is just cut that number in half, and that would be 85 degrees. And there's my answer. So we're using 360 to find the angle that it goes with, because this goes with this. This one would go with that one right there, the one in the yellow. Alright, this is a similar problem than what we just did. We have 260 over here, but in order to find the question mark, I need this arc length over here, arc measurement over here. So if I got 260, that means I take 360 minus 260, I get 100. So this is 100 degrees. To go from big to small, I once again divide by 2, so my answer to this one is 50. That's half 100. So remember, we're using the concept that the whole circle is 360. There's this arc over here, and this little arc over here. Those two have to add up to 360. Alright, see, these are more problems like what we just talked about. You can see here 65, but we want to know this. That doesn't go with it. I'm going to show you two ways to do this, actually. There's another couple of ways. I'm going to do the left one way. I'm going to do the right one a different way. So let's do 65, and we know this is 130. I got 130 because the whole theorem we've been talking about today. 65 times 2 is 130. Then remember, these two arcs from here and here have to add up to 360. So if I take 360 minus 130, it's 032. So the answer is 230 degrees. Now that was one way to do the problem. So I'm going to show you a different way. You can see this is 240. That means this huge arc here. I'm going to find this angle right there, which is 140. If you're questioning how I got 140, I just took half of 280. And that got me this arc. Now you can do the same thing we did in this left problem and take 360 minus 280 and divide by 2. Nothing wrong with that. But I'm going to divide by 2 first. But if you notice that this angle here and this angle, they do not add up to 360 anymore. They actually add up to 180 because this is a straight line. These two have to add up to 180. So all I have to do is take 180 minus 140. You have 40 degrees. And there's my answer. Now if you're thinking, wait, would I get the same answer? Well, yeah, if I took 360 minus 280, do a little bit of math, get 0, 2, 16, 8. This comes out to be 80. 80 divided by 2 is 40. So there's two ways to do that. It's up to you guys. You guys choose which one you want. Alright, last two problems here. Similar to the one we just talked about in the last slide. Remember the two ways I showed you how to do it. You can go here. Let's say I'm going to do it the other way for here. So if this is 52, this angle right here has to be 180 minus 52. So let's do a little bit of math. 128. Remember, these two angles right here have to add up to 180. It's a straight line. So 128 times by 2, and that's going to give me my question mark. So all I got to do is take 128 times 2. I get 256. I would still get the same answer if I went from here, find the arc, and took 360. So let's do it this way here. 360 minus 210 is 150. Then divide that number by 2. That's 75. So the question mark is 75. Now we got the same thing. If I took 210 divided by 2, I get 105. Then 180 minus 105 give me 75. You can see both ways give me the same answer.